I'm Nora.
I'm Cindy.
And this is our second project for 67364. So we're using the Pet Finder dataset from Kaggle.com, which features data from the Malaysian Pet Finder website. And we are trying to predict the speed at which a pet gets adopted, which is encoded as a categorical variable based on different characteristics in their Pet Finder profile. And we thought that getting a better understanding of how the profile affects adoption speed might help different parties, from pet finders to the shelters themselves, get pets adopted more quickly. Reading this data set, we saw that there are a lot of categorical variables, which is a challenge we wanted to keep in mind for our future model development, because they're on wildly different scales. So we wanted to make sure that there was some sort of processing done to work with all these different categorical variables. Additionally, the dataset, since it's from Malaysian Pet Finder, there are a lot of non-ASCII characters. A bunch of the descriptions are written in Chinese, so when we're working with the descriptions, with feature engineering of the text in the descriptions, it was important for us to clean the dataset and remove these descriptions that have non-ASCII characters, and drop the null rows in the dataset.
Another data processing that we did on our data set was mapping the states column to population. Initially, in our original data set, we were given the state column with just an ID. So what we proceed to do is to map the state ID to its corresponding population, which we thought would be more representative of the differences in the states.
Our first step was we wanted to do some initial visualization of the different categories, and see which were promising to sort of focus our models on. And also we wanted to look at the distribution of the different variables to see if there were any sort of anomalies or things we should keep in mind when looking at the data set. But first we looked at adoption speed and how it was correlated to the state population, as Cindy mentioned before, the video amount and the photo amount. And as you can see, the adoption speed seems a little bit more related to the video and photo amount than the state population distribution, as you can see with the curve in the lower left corner. And we thought that this was promising because those were things, the video amount and the photo amount were things that could be changed, whereas the state where a potential adopter lives doesn't have it cannot be changed because the pets are, hard to transport. Additionally, we wanted to look at the adoption speed and fee, age, and breed, because those seemed like sort of variables about the specific pet that might be important to the adoption speed. And we found things that were similar to what you might think. Pets that had lower fees and were younger tended to be adopted faster. So we used, sort of similar to our first feature engineering homework, just some basic text analysis. We tried it with the multinomial naive Bayes model, and it yielded a pretty good score. We tried it with the Bernoulli naive Bayes model, and it was slightly lower, but still around the same score of about 0.35. And then specific feature engineering yielded a much better result with incorporating bigrams, yielding a 0.03 jump to 0.38, and incorporating a custom stop word set. As you can see, the common words used in the data set, like kitty, funds, rescued, which might not affect the quality of the description, but are more just common used words about cats and dogs and different pets getting adopted. That actually bumped it all the way to 0.39, which we were pretty pleased with because this data set was actually used in a Kaggle competition, and the top scoring model was 0.44. And this is pretty close to that, and we didn't even use the Google API that they suggested people use for image analysis and sentiment analysis of the different descriptions. But we also wanted to incorporate other features into our final model because we didn't want to lose the valuable information that the other features might provide.
Yeah.
And we wanted to try other more complex models and see if there is anything else that we could do to improve the score.
And that's why we started to experiment with different models and see if we can get a better performance out of different models. The first one we tried was decision trees, and we would like to choose this model because we thought that the feature selection that decision trees supported will be very helpful for our model, our data set specifically. So as you can see here, the score is about 0.32, which is not bad. And
but still not as good as our first models.
yes. And so our next one is to try binning the binning the continuous data, because we have two specific variables that we wanted to look at. For example, first one is the fee, and another one is the age. You can tell from the visualization that we provided here, they're very skewed. So we believe that binning might help normalize the data and might improve the performance. And also, after that, we thought about the idea of constructing a pipeline. For example, right here, you can see that we split the attributes into 3 different categories and apply different transformer to it so that we believe fit. Afterwards, we tried two more models. The one is a random forest, which you can see here that did a little better than the decision trees. And also we tried the KN, which is a K nearest neighbors, which did about the same level.
We wanted to retry the pipeline because we had worked with these more promising models. We wanted to see how we might be able to combine it with the text analysis count vectorizer.
Model.
And so we created this pipeline which transformed the numeric, the categorical, and the text columns differently using scaling numeric columns, one-hot encoding the categorical columns, and then using our count vectorizer model on the text columns. And this yielded, or not very good results with our forest model, our random forest model, fine results with our kth nearest neighbor model, but our highest results using all of the variables with our decision tree model.
We thought that there's some very interesting results that we found with our features. For example, the description feature we believe is pretty important, considering that our one model with just description give us the best performance overall. And we believe that also adding information such as the second breed of the pet is very useful as well, since we saw a boost in our model performance. So we believe that our project is very valuable to either the shelter who post information of the pets on website like Pet Finder, and also for websites like Pet Finder that help people find pets that they want to adopt, because for the shelters they could learn from our project that which information are more important to post so that they can boost the speed of their pets being adopted. And also for the website, they could optimize their website design to display the information that would be useful for people looking for pets to adopt. But in the end, we just want our animal friends to find home.
Thank you for watching our video.